All right, this is another question from one of the exams, and from exam 2. And we have a Henry's Law question. So we have at sea level, the given temperature, the partial pressure of argon. So what we would have is the pressure of argon being 0.01 atmospheres, and that gives a concentration, I'll just write C, of argon in water of this. So we have a solubility of this in water, kind of as I guess as you're reading this, the indication that it's Henry's law is you have a pressure of a gas, and then you have that gas in some kind of solution in, in this case, in water. So what we have, if we recall Henry's law, is something that looks either like this, or it just depends on what kind of units you want to use for the concentration. Sometimes we use mole fraction for how much of the gas is in the water, or this is just a general C for concentration, which could be molarity or it could be molality. Really, you could use whatever units you wanted. The key is that the pressure of the gas and the concentration are proportional. This Kh, remember, is just this constant, right? Henry's law constant, which again will just differ based on the units that you're using. So pressure proportional to concentration, that's kind of the key. And I'll show you how you can use that to your advantage, maybe with a quick way to do this problem. So one way to do it would be to just kind of plug in and find Kh. So you could plug in like the pressure of the argon and then say Kh and then the concentration. So we have the moles per liter, right? So I'm just using this one here based on what's given in the problem. And then Kh would be 709.2. If you kind of kept track of the units, it would be atmospheres over molarity or atmospheres times liters over moles, whatever way you want to write it. So then you could use that to find the pressure, in another scenario where in some other solution, you have the concentration being this is kind of what's given, and then you want to find, the pressure. So basically then you're going to, again, use this and say, like, I don't know my pressure, but I know this Kh constant. And then the concentration in that case was 6.3 times 10 to the negative 4. So that gives us a pressure above the solution of 0.447 atmospheres. Right. Alternatively, what I tend to do in some of these problems, and it's just again from seeing a lot of them and practicing, is that because pressure and concentration are proportional, you can use a ratio like P1 over P2 equals C1 over C2. Again, if you're using mole fraction, you could just write this like this, because again, mole fraction is just a different concentration unit, but it's the same idea that the higher the pressure, the higher the concentration, vice versa. This is kind of a good skill to know how to write these proportionality equations. And you could also do something like this. P1 over C1 equals P2 over C2, right? It ends up being the same thing. It's still algebraically the same, just kind of how you want to think about it. And then you would just have, like, let's say like P1 being 0.01 atmospheres, and this being your initial, or your concentration that went with the pressure of 0.01, and then P2 would be what you're trying to solve for, and C2 would be 6.3 times 10 to the negative 4 moles per liter, right? So in the same way, if you did that, you solve for X, it would be, you would get 0.447 without even having to find the Kh, the Henry's law constant. So just a quick thing. And again, the concept would be like higher pressure means more gas is dissolved in the solution, so you have a higher concentration. Lower pressure of the gas means lower concentration. So you can kind of check your answers too, just by thinking about if that makes sense. Okay, so that's how you would do that. and talk to you later.